RCDs, the best way to guarantee electrical safety at home. Our civilization is largely dependent on electric power, but it can be dangerous for people and equipment. An electrical failure can be a source of electric shock and fire. To prevent such risks, it is necessary to identify failures and secure the system as soon as possible. Some fault currents, although low, could be dangerous, but are not sensed by miniature circuit breakers installed for overload and short circuit protection. For 50 years, ABB has contributed to the development of a particular type of device designed for protection against leakage current, also by introducing innovations in the market. RCDs were launched in the market in the 50s. They were initially used by some utilities to fight the energy theft due to the use of currents from phase to earth instead of phase to neutral. With this scope, in 1953, ABB built the first low-sensitivity RCD. And in 1956, a device with high sensitivity. RCDs are now widely used in most of the world to protect people against electric shock and prevent fire. Effects and dangers of electrical current on the human body. Electric shocks have 4 physiological effects on the human body. Neurological effects, thermal effects, muscular contraction, respiratory arrest and cardiac fibrillation, indirect trauma. The extent and magnitude of damage depends on the value of current flowing through the body, the duration of the electrical current flow, the path of this current flow, and which organs are involved. Electrical leakage can cause danger to people and also lead to fire accidents. Usually no reaction. Usually no harmful physiological effects. Usually no organic damage to be expected. Likelihood of cramps, contractions and difficulty in breathing. Reversible disturbances of formation and conduction of impulses in the heart, including atrial fibrillation and transient cardiac arrest without ventricular fibrillation, increasing with current magnitude and time. In addition to the effects of Zone 3, the probability of ventricular fibrillation increases up to about 5%, curve C2, 50%, curve C3, and above 50% beyond curve C3. Pathophysiological effects such as cardiac arrest, breathing arrest, and severe burns may occur, increasing with current magnitude and time. Why is 30 mA the preferred value for RCD sensitivity? 30 mA is generally considered a safe level of current through the human body, and whilst you might feel it, it is unlikely to harm or kill you. When a current exceeding 30 mA passes through a part of the human body, the person concerned is in serious danger if the current flow is not interrupted in a very short time. Electricity is dangerous when a part of the human body influences the flow of current. This happens when the body becomes part of an electrical circuit connecting 2 points at different potential. Typically, the 2 points become live parts through the body to earth to which the transformer is connected. If you touch a live part with one hand, you'll have a current from the contact point through the body that will reach the feet, and from there, through the ground, return to the transformer. It's for this reason that if you wear a pair of insulating shoes, even if you touch a live part, you don't risk electrocution. Indirect contact. An indirect contact refers to a person getting in contact with an accessible conductive part which has become live in consequence of an electric fault. The methods of protection against indirect contacts are classified as follows. Protection by automatic disconnection of the supply. Protection without automatic disconnection of the circuit, double isolation, electrical separation and local bonding. Extra low voltage power supply. RCD realizes protection by automatic disconnection of the supply. Direct contact. Direct contact refers to a person coming into contact with a conductor that became accidentally accessible. The methods of preventing direct contact are mainly concerned with being sure that people cannot touch live conductors. By insulation of live parts. This is the standard method. By enclosures or barriers to prevent touching. By placing out of reach or by placing obstacles to prevent people from reaching live parts. The use of RCDs gives people additional protection only when contact is from a live part to an earthed part. Additional protection. An additional measure of protection against the hazards of direct contact is provided by the use of RCDs, which operate at less than 30 mA and are referred to as high-sensitivity RCDs. High-sensitivity RCDs, sensitivity equal to 30 mA, provide protection against both indirect contact hazards and direct contact dangers, ensuring complete protection. Additional protection is required for specific use by IEC 60364-441, as shown in the following table.